working on to make sure we feel comfortable about the situation. Drama, music. Okay. So I know I already touched upon this, so let's kind of run through this quick on page 89. The first thing you want to do before, unless they have told you, it does look like, so let's see, I add 9 and 15 and 7 together, so 9 and 15 is 24, 7 is 31, so 43 is our total amount of people in here, okay? So they won't always give you that information. What you have to make sure, if they don't give you the information, is you make sure you add up all of these numbers in order to get that 43. That's pretty easy, I believe. Okay, and then we can just talk through these real quick. So, probability they like drama. So you have to add the 9 and the 15 together to get 24. So basically, what you think about this Venn diagram being is, let's pretend we have the 43 people are in this room at this point in time. And then what I do is, everyone wrote down if they like drama, if they like music, if they happen to like both, if they didn't like either. Okay, that's our three things. So if I say, hey, if we like drama, we have the 9 people who solely like drama, but we have the 15 that like drama and music. Okay? And I think drama is a class, not drama as someone being a tick turd.
No way. Do you like being a drama queen?
Yes. All right. So the probability they don't like drama would be the 7 people who like music only, and then the 12 people who didn't like either. So you have 19 out of 43 there. And these are all bases. The chances if I were to pick people randomly, what's my chance of picking them in those cases? They don't like drama and music. Okay, they don't like, or they like drama and music. So it's the overlap of the two Venn diagrams. So you have 15 out of the 43. And I realize the answers are there, so it's pretty easy to follow along, I hope. Just let me know if you're not seeing where they come from. And then the probability they like drama or music. Okay, so drama is 9, music is 7. So they like this or that. There's no one that overlaps. So you add the 9 and the 7 to get, they like drama or music. Yeah, you add them all up. So you could have the drama, 9, you could have the music, 7, and then you could have the overlap as well. So you add 9, 15, and 7 together to get that 31 out of 43. Okay? And then you start changing the denominator when it becomes a conditional probability. So let's focus on, I don't think I talked about the conditional probabilities on these, but let's just make sure we feel okay about this. They like drama such that they like music. Okay, so first thing, when I do these, when I think of this as like the fraction sign, even though it's not. So this means this is the bottom number, and this becomes the top number, or numerator, denominator, okay? So the amount of people who like music is 15 and 7. So that would give me 22. So basically what I did in this case, saying, all right, if you like music, stay here. So you have the 15 who like both, and then the 7 that just like music, they stay here. Everyone else leave. And then, okay, what's the chance that I pick somebody who likes just drama? So that would be they like drama such that they like music. Okay, so what we have to do is this. They like drama and they like music. So think about this. This category right here, this circle right here, is what is going to take place that we're going to do. So my numerator has to be 15. Okay?
I don't understand. That's why I'm looking at this right now. I don't understand.
I can't laugh anymore. I'm sorry. So does that feel like a weird laugh, you know?
I think that's your normal laugh.
No, it's not, Alex. You haven't heard my
My
normal
bad,
laugh.
I'm sorry.
All right, that's actually.
So. Can you explain how you got 15? Because I don't understand.
Okay, so,
I get the denominator. But
okay, so see how I circled the music such that they like music. I want only the music people, only the people who like music at some capacity, whether they like music, huh?
That's only 7, right?
Right, but also these 15 also like music.
Yeah.
So you think about this, that green circle idea, those are my people who like my music. That's where the 22. Okay, so then they like drama. So basically what I did is this. We have the 43 original people. I say, okay, whoever likes your music, stay here. So everybody else of the 43 people, bunch of people walk out, the 22 stay behind. Of those 22 who are still sitting here, there's only 15 of them that also like drama. So that's why this becomes a 15.
Oh, because they like drama and okay, I got you.
So think about how I did that green circle.
Yeah.
That green circle are the only people left in the class.
Not because of the 15, because it's between both, because they like
Mhm.
drama and,
Yeah.
because like, the only thing that makes the denominator is if they like music or drama.
Mm-hmm.
But no matter what, they'll always be 15 because they always like both.
Right.
Got it.
So this is going to be music such that they like drama.
Yeah.
So the drama becomes my denominator. So now it's going to be this circle here. Okay, so that means I have 24. So I have 24 people still sitting in the room. The other 19 people are out in the hallway. And I say, okay, what's the chance that I find somebody who likes music such that they also like drama? So that would be the 15 out of 24. Okay, so sometimes it works better if you circle your group that you're focusing on. And then let's see. Probability they like music such that they don't like drama. Okay, so what we're going to look at here is they don't like drama. So I'm going to look at, where am I at? The music such that they don't like drama. Okay, so basically I'm going to eliminate, I think they have the denominator wrong here. Hang on, I just think about it too much. They don't like drama. So this person does not like drama. Agree?
Yeah.
But then also these people.
Is that supposed to be 21 or 12?
What's it, 12?
Yeah.
Oh, thank you. Oh my gosh. That's why I thought there was a mistake in the book, because I can't write down the right thing. My dyslexia kicked in nicely. It's like, sir, if you're making fun of people with dyslexia? No. I seriously think I have it sometimes. All right.
Really?
Yeah.
Have you ever been like diagnosed or checked for it or?
No, back when I was a kid, we didn't go to the doctor for everything. We just rubbed dirt on it and called it good.
You go to the
All
doctor, they might
Touche,
find
touche.
something that's wrong with you.
What?
right.
Are you just eating straight strawberries with nothing else? Kind of random.
They're good.
Strawberries are good, but like,
Why are you asking so many questions?
why not just strawberries and blueberries together? Like, I don't know. Cantaloupe.
Strawberries and blueberries.
Wait, what?
Strawberries and blueberries.
I have no idea. You know, my brain goes all over the place, you know?
We can talk about it.
All right. So now that I have my numbers right, do you see where I get the 19 from? Now that the numbers are right, do you see where I got the 19? So, and then they like music, so then there's the 7 out of 19. Okay, now, Venn diagrams, can also have 3 circles. So if you go over to,
Wait, this is confusing. Can you explain again quickly why it's only 7 instead of 22? Because wouldn't you add the 7 and the 15? Because those
Good,
15 like
good.
music as well.
I love what you're saying. All right. So
Why are you mad at me?
it was this one, right?
Yeah.
Okay. We have 43 people in the room. I say, hey, if you don't like drama, step out. So these 9 and these 15 are gone. They walk out. That leaves me the 7 and the 12 to give me the 19.
Oh,
And then I
because the 15 walk out of the room because they don't like drama. Okay, yeah, that makes more sense.
I thought the 15 do like drama.
But they don't.
They don't like drama.
Yeah.
So these people also like drama. These people like drama. So these 24 people will walk out. It's
Yeah.
9 and 15.
Oh, okay.
And then I'm left with the 7 and the 12.
So the people who don't like drama stay in the classroom now.
Right.
Okay.
All right. So yeah, I ignored it. All right. So now we're going to increase the Venn diagram.
I'm glad I had it.
So
I set my alarm 5 times at 1 a.m. and 4 times at 3 a.m. Why did I do that?
No.
all right. So these are this is basically saying I have a collection of students that have Spanish, chemistry, math, but I happen to have 5 of them that don't have any of those classes. There's 85 that are only in math, 60 that are doing math and chemistry, 17 that are only doing chemistry, 3 that are doing chemistry and Spanish, 15 that are doing all 3, 5 that are doing Spanish and math, and then 70 that are only doing Spanish. All right, so first thing I have to look at, I need to add up 70 and 3, that's 73, 73 plus 17, 80, 90, 105, 165, 170, 170, am I right? Am I okay so far? 85 and 5, so 170 and 90. I'm just adding up all of my, come on, this is freezing up on me already.
It's okay.
All right, I gotta redraw this. So friends, I will tell you this. Once you get to 3 categories, that's basically the most you want to have as a Venn diagram this way. There's another way to draw Venn diagrams, which is like concentric L's.
That's a lot of spaces. That kind of hurts my head, Stra.
Sorry. It's just how Venn diagrams roll. How many did I get here? What did we add it up to? 260? So the total is 260. All right. So the probability there is the overlap of all 3. So this right here, the 15 out of the 260. So all 260 people, it's kind of crowded in here with 260 people, but let's pretend. Chance that I pick somebody who has all 3 classes out, I have a 15 out of 260 chance of that taking place. And then I have the probability that they are doing Spanish and chemistry, but not math. Okay, so I still have all the people in the class, still the 260. So the Spanish and the chemistry there's only 3 people that are doing Spanish and chemistry and not math. Okay, so again, if I had the 260 people in the class, if I pick somebody out of the class at random, I have a 3 out of 260 chance that person is taking Spanish chemistry only, based on our data. Okay, and then let's see, probability that they are in math, but not in Spanish or chemistry. Oh, dorked up on me again. This was doing so good for the past couple days, and now it's even shut it down overnight. All right, so I'm not going to go back to my thing. So probability, they like math, but not Spanish or chemistry. Okay, so I still have the 260 people in the class. So what's the chance that I pull somebody who is in math, but not in Spanish or chemistry? So that's the 85, that very bottom number of our circle. Okay? Now we start getting into conditional probability. Now I have to draw this back again, but I'm not going to put all the numbers in. Okay. So now it's going to be probability that I pull somebody that has Spanish such that they're in math. Okay? So the people that are in math, this is the circle we're dealing with here. Okay? So that's going to give me, if I add up the 5, 15, 16, 85, that gives me 165 kids that are in just that purple circle. And then I say, okay, they are in Spanish. They're in Spanish. So this is where this is going to take place. It's going to be here, these two categories here. So I'm going to add those together. So I have a 20 out of 65. Okay? So basically what this means is I have the 260 people in the class. Say, okay, everybody who's in a math class, stay here. Everyone else go out in the hall. So there's 165 people sitting there. Of those 165 people sitting there, they also happen to be in Spanish. So it's the overlap, the 15 of all three, and it's the 5 that are just in the Spanish and math. And then, let's see, the probability that the student is in Spanish such that they're not in chemistry. Okay, so I bring all the 260 back in, saying, okay, whoever is not in chemistry, stay here. Everyone else who is in chemistry gets to go away. So basically, they are not in chemistry. So this circle here is going to be ignored. We're going to ignore this circle. Okay? So anything that's outside of that circle is going to become my denominator. So I have 75 and 85. So it's not in chemistry. So I have to remember I have to count these people over here too. So if you're not in chemistry, stay here. So the 5 people that aren't in any of the 3, plus the 75 and the 85, here, here, and here, get added up. That becomes my denominator. So now I have 165 people in the class. And then I say, okay, of those people that are not in chemistry, so the blue circle left, that means just in Spanish I had the 70 and the 75, or the 70 and the 5 to give me 75. Does that make sense? So that blue circle that I circled, the 17, 3, 15, and 60 are out. Okay, because they're in chemistry. But I don't want them in chemistry because, let's face it, chemistry is just chemistry. All right. Though I'm certified to teach it. All right. Now we have student in chemistry such that they are not in math. Okay. So the math category is this category. So I'm going to circle this category here. All those people in that category, the 5, the 15, the 60, the here, the here, the here, and the here, and the 85 are out of the room. Okay. Those people are gone. So now I count up the 17, the 3, that's 20, plus 70 is 90, plus the 5 that outside, that's our 95. Okay. So then I look at those people who are in chemistry. Yeah. Yeah. So you're counting this group here and this group here. So your 17 and 3 gives you the 20. And these 2 dots here this dot here and this dot here, they are not in, these people already left, so we're not even counting these people. So I'm just looking at the orange dot and the orange dot as my numerator, divided by this, and this added together, which gave me the 95. Yeah.
It'll be, like the circles would be much, and the lines would be much bigger than that on the test, right?
I'm gonna make them smaller just for you.
Yeah, but I can't even see. Like,
You're gonna bring in a microscope.
oh God.
I'm just kidding. I'll make it big enough for you.
Maybe I will bring in a magnifying glass.
Just have your phone, have your camera, and it's how this guy has to read menus these days. All right, last example. The probability that they are not Spanish such that they are in chemistry. Okay, so our chemistry circle is this. I say everybody who is in chemistry stay here. Okay, so if I add up the 17, 3, 15, and 60, that gives me 95 as my bottom number. Those are in chemistry. And then they are not in Spanish. Not in Spanish. So that would be this group here is not in Spanish, and this group here is not in Spanish. So those two pink regions. So 17 and 60 is 77, so I have a 77 out of 95. The one last thing I want to say to you is, let's say we have 4 categories. This is how a Venn diagram starts taking place if you have 4 or more categories. I think I can draw this. You have this L, and then you have like this L. Let's do a different color. Oops, don't go up that high stroke. And then you have this L. And then you have one more L. This is basically how you start looking at Venn diagrams when you have 4 or more things. And I'm just showing you that, not that you ever have to know it as far as this class goes, but I've seen Venn diagrams where you have 5 comparisons, so you have like these seated L's, you have 5 of them. So I think this is where everything takes place, and then it goes from there. So that's how they do it. Rather than trying to draw concentric circles like this, I mean, I guess theoretically you could do that, but trying to get 5 circles that have overlap, yeesh. I mean, yuck. And all the Venn diagram is a visual
You
representation.
have to do 5.
No, you're not going to even have to do 4.
Yes, right.
I got you covered. All right, I want to give you the rest of the time to get a really good start on page 203. Let's see, 203. I think page 203 would be enough. Deal?
I think it's